Good evening, everyone. Welcome to our live stream webinar. We have invited two speakers who are very proficient in the field of mathematics. But before I present them to you, let me share with you the cornerstone of the IGP, the mission, vision, and the core values. The mission is to provide learners, pre-service teachers with solid foundation of knowledge, skills, and the right attitude and help them become confident learners and educators and able to compete globally. The vision is continuously grow, expand, and provide quality and excellent service to every learners, the service educator around the world. And for the core values, the IGP upholds integrity, righteousness, honesty, and serving, bounded with principles and high standard of social work, particularly the values of self-determination, empowerment, and respect of diversity. And now, let me introduce our first speaker. He is a math teacher at Sabang Elementary School, Bulacan, Philippines. 3 years as district mathematics coordinator, master degree student at La Consolacion University, Philippines. Trainer and winners in the Philippine Sudoku Super Challenge. A professional developer of video math lesson, which he regularly uses in his teaching. Now may I present to you Sir Nico Banan. Sir Nico Banan will be sharing with us the ratio and proportion. Welcome, sir.
Thank you, sir. Good evening. Thank you, sir Nestor.
Okay, sir. It's your turn.
Okay, so good morning, good afternoon, or good evening to all the viewers and participants of this webinar. So for our session today, it is about teaching and learning mathematics. So by the way, my name is Nico Ibanan, teacher 2 of Sabang Elementary School. So you can call me Sir Nix. That's the name of my YouTube channel. So you can go and visit my channel if you want. So before we start, let me first have this quotation. And never think that what you have to offer is insignificant. There will always be someone out there who needs what you have to give. So in this webinar, I request every participants or viewers to empty their cups. I want you to absorb all the knowledge that the speakers will teach you or will share with you, so that all the topics that we are going to deliver will be still significant to everyone. So by the way, um, what I'm going to teach you first is about creating video recording using a Zoom application, because actually I started doing my YouTube channel, my content about mathematics last May 2020. So I decided to create video lessons using Zoom application because, of course, at this time that we are still under the pandemic, so we have to really innovate or do something so that our learners will still learn the topics or concepts in mathematics. So not all our learners can actually attend our online classes. So I decided to create my video recording using a Zoom application for those who for my synchronous teaching. So for those participants or viewers that do not have yet the Zoom application to their computer, so I'll be giving you 2 minutes to download the application so that later on you can actually go along with us as we go further with our Zoom application or the video recording using Zoom. So this is the link. So you just go to Google and then look for the installer for Zoom application. So I'll be giving you 2 minutes to download the Zoom application if in case you do not have it yet in your computer. So you only have 40 seconds to download and install the application. Okay, so time is up. I hope that everyone has the application now or the installed application now in your computer. So this time we are now going to explore how to create video recording using Zoom application. So this is what I used in doing my videos in my YouTube channel. So of course, before you start doing your video recording, make sure that you already open the the PowerPoint presentation that you would like to share or do a video recording. So please take note of that before you start. And of course, if you want to add music while you are having your video recording, you have to open it already before you click the install Zoom application. So do not forget, you have to first open your presentation that you're going to use in your video recording. And of course, if you want to add music, you need to open already the music player of your computer. So that's the first step. Then after that, you can now double click your Zoom application installed in your computer. Then next, after you click the installed application of Zoom in your computer, so this will appear now in your computer. So there is new meeting, join, schedule, and the share screen. So what are you going to click? So since you are going to create your video recording, you have to click, of course, new meeting. So click new meeting in your computer. So I hope you are all following the steps so that you can create your own video recording for your learners who is using asynchronous teaching. So I hope you are done with this. Then after that, after clicking new meeting, so this will now appear to your computer. So you will see yourself because when you click new meeting, it's automatically that the camera of your computer will open. So you will see yourself on the screen. Then after that, if you are ready to share your presentation, of course, you have to click now share screen. So after clicking share screen, so this will appear now in your computer. So just like at what I told you, you have to prepare first or you have to open the presentation that you want to share. So in this case, I want to create a video recording about Math 6 Week 1 Quarter 2 in Mathematics. So I have to click this presentation, and of course, if you have sounds, so you have to click share sounds. Then after clicking share sounds and your presentation, you may now click share. Okay, so I think you are all done with these steps. Then after that, after clicking share, you may now click slideshow. So you're going to click slideshow so that you can now start with your video recording. So after clicking slideshow, click from beginning so that the presentation will start from the start of your lesson. Just like this, ratio and proportion. So after clicking from beginning, so this thing will appear now to your screen or whatever presentation you share in your computer. So after this, you can click that one, the one that has a red box, if you want to turn off your camera while you are doing your video recording. So just like this. But if you want to see yourself while you are doing this video recording, you have to click the other one, the bigger rectangle. So after clicking that, then of course you will see now yourself. So it's up to you if you want to turn on or turn off your camera while you are doing your video recording. So the topic is about ratio and proportion. Then after that, you have to click you are sharing or you are screen sharing, the green one. So you have to click that you are screen sharing. So after clicking that, so this will appear. So you have to choose more or the three dots at the upper right corner of the screen. So after clicking that, so this will appear now to your computer. So chat, record, meeting info, and so on. So if you are ready to create now your video recording for the asynchronous teaching, so you may now click record. So after clicking record, what if, sir, I want to take a break before I continue my recording? So what you are going to do is go back to more and then pause recording. Then if you are ready to continue your video recording for your asynchronous teaching video lesson, so you may now click start recording. Then after that, if you are done with your presentation and you think it's good enough for your asynchronous teaching, you may now click stop recording. So after clicking stop recording, so this thing will appear to your screen. So after that, you have to click stop share. So I hope all of you are have having still following the steps on how to create this video recording. That's very easy. That's basic. So I know that everyone can really do their video recording after this session. So click stop share. Then after that, you have to click end. So after clicking end, so this will now appear to your computer. End meeting for all or live meeting. So I usually click end meeting for all. So after clicking end meeting for all, so your video recording will automatically convert the meeting recording. So this will appear to your screen. So you just need to wait for about a minute or two before the full video recording will appear like this. So you have to choose audio only, playback, or Zoom. So if you want to have, of course, your presentation, the audio, so you have to choose Zoom, the one that has the yellow box. So you have to click Zoom. Then you have to rename it whether it's about ratio and proportion or other topics in mathematics. So that's how easy I create my video recording, which I upload in my YouTube channel using Zoom application. So I hope everyone follows with the steps that I gave to you. So here are the sample of my video recording made for my first quarter in Mathematics 6. Then of course, this is my video recording made for my second quarter in Mathematics 6. So we have addition of integers, comparing of integers, the concepts of percentage, base, and rate, direct proportion, division of integers, and so on. So that's it. That's how simple we can create our video recording using Zoom application. So do you have any questions about our first topic? So that's the first part of our topic. I'm just sharing, I'm just sharing to you the ways on how we can create a video recording using Zoom application. So if you do not have any question, I think we can now proceed with our overview or introduction to one of the topics in mathematics, and that is about the ratio and proportion. So let's have now the introduction to ratio and proportion. So first, we need to define what is a ratio. So I know that some of the viewers or the participant of this webinar has the idea about ratio. So when we say ratio, ratio is the comparison of two quantities or numbers. So for example, if you want to compare the numbers of chairs or tables in your house, so we actually create ratio. Or for example, in school, if you want to compare the number of boys to the number of girls in your class, so you are already creating a ratio. So it's a comparison of two quantities or numbers. Now, after knowing the definition for ratio, the simple definition given to ratio, we can now discuss the parts of a ratio. So what are the parts of ratio? So we need to be familiar with the parts of a ratio. So the parts of a ratio are, of course, we have the antecedent or the first term. And of course, we also have the consequent or the second term. So again, do not forget the parts of a ratio is the antecedent or the first term and the consequent or the second term. So let's have an example. We have three bags to two person, which among the given quantity represents the antecedents. If your answer is three bags, then you are correct. Eh, which of the two quantities represents the consequent? If your answer is two persons, then you got it right. Another example, five families is to one house. So which of the two quantities represents our consequent? If your answer is one house, then you got the correct answer. How about the antecedent? If your answer is five families, then you are correct, since the antecedent is the first term, and in this given example, our first term is five families. Another, eight teachers over a school. So which is the antecedent and which is the consequent? In this case, eight teachers represents our antecedent or the first term, and a school represents our consequent or the second term. So again, class or to the viewers or the participants of this webinar, do not forget that the parts of a ratio are the antecedent or the first term and the consequent or the second term. Let's proceed. Ratio may be written as, so we can write ratio using first the number place, second using fraction form, and third using colon form. Let's start with the number phrase. So I have here some figures. We have stars, circle, triangle, and rectangle. So now we are going to form a ratio using number phrase. But remember, in writing ratios using number phrase, we use 2 to separate the given quantities or numbers. So let's start. Can you form a ratio using these two quantities, the number of stars and the number of triangles? If your answer is 5 stars to 4 triangles, then you are correct. So we have 5 stars on the screen and we have 4 triangles on the screen. My question now is, which of the two quantities represents our antecedent? If your answer is 5 stars, then you are correct. How about the consequent? Now, if your answer is 4 triangles, then correct. Next, let's form a ratio using the number of rectangles and the number of circles. If your answer is 5 rectangles to 6 circles, you are correct. Now, which of the two given quantities represents the consequent or the second term? So if your answer is 6 circles, then you are correct. And which represents our antecedents? If your answer is 5 rectangles or 5, then correct. So that is one way of writing ratio using number phrase. Question? Now, let's have our fraction form. Writing ratio using fraction form. So in this case, I have different fruits. We have apple, pineapple, oranges, and mango. Now, let's form a ratio using the following given fruits. So can you create a ratio using the number of mango to the number of oranges based on the given illustration? Okay, if your answer is 1 mango over 4 oranges, then you are right. So we only have 1 mango and we have 4 oranges on our screen. Now, which among the given quantity represents our antecedent? If your answer is 1 mango, then you are correct. Which among the given quantity represent our consequent? If your answer is 4 oranges, then correct. Let's now form another ratio using fraction form with this given fruits. We have pineapples over the number of apples. So you count. If your answer is 4 pineapples over 3 apples, then you are correct. Now, which of the two quantities represents our consequent? If your answer is 3 apples, then correct. How about the antecedent? If your answer is 4 pineapples, then very good. So this is another way of writing a ratio using fraction form. And finally, we can also write ratio using the colon form. In this case, I have different pets. I have dogs, birds, and cats. Now, let's create a ratio using these animals or pets. Remember, in writing ratios using colon form, we read colon as is 2. So please take note of that to our viewers or participants. The colon is read as is 2 when we use colon form in writing a ratio. Let's start with the number of cats to the number of dogs. If your answer is 2 cats is to 5 dogs, then you are correct. We have 2 cats and we have 5 dogs. Now, my question is, which among the quantities represents our antecedents? Again, the antecedent is the first term in ratio. So if your answer is 2 cats, then correct. Now, if the question is which among the quantities represents the consequent and your answer is 5 dogs, very good, because 5 dogs is the second term given in this particular ratio. Question? Now, let's proceed with another ratio. We have the numbers of birds and the number of cats. So please count the number of cats and the number of birds. Now, if your answer is 3 birds is 2 cats, then your answer is correct. Now, which among the two quantities represents our consequent or the second term? If your answer is 2 cats, then you are correct because 2 cats is our second term in this given ratio. And which among the two quantities represent now our antecedent? If your answer is 3 birds, then you are correct. 3 birds represents our antecedent. So always remember that we can write ratio using first the number phrase, second using the fraction form, and third using the colon form. Any question? Okay, thank you. Now let's proceed with proportion. So a while ago we talked about what is ratio, the parts of ratio, and the three ways on how we are going to write ratio. This time, let's talk about proportion. So proportion means two equivalent ratios. So still we are comparing numbers or quantities. But in this case, in proportion, two equivalent ratios. So they should be equal so that we can call it proportion. So let's have an example. Parts of proportion. Of course, we need to identify the parts of proportion. If we have antecedent and consequent in ratio, in proportion, we have the what we call the extremes. The extremes are the first and the last term in a given proportion. And of course, if we have extremes, the second part of a proportion, is the second and the third terms. So let's have an example. So we have 2 is to 3 is equal to 4 is to 6. So in this case, let's identify which is or which are the extremes. It says that it's the first and the last term. Now, if your answer is 2 and 6, then you are correct. 2 is our first term and 6 is our last term. So it composes the extremes. The first and the last term is called extremes. And of course, to identify the means, we have to look for the second and the third term in this given proportion. So our second term is correct. The answer is 3. And for our third term, very good. The answer is 4. So our means is 3 and 4. If we are going back to the definition given to proportion, it's two equivalent ratios. So for us to be able to identify if the given proportions or equal, we have to get the product of the extreme and the means. To tell them if they are proportion, we have to get the same product of the extreme and the means. So let's multiply the extremes. So we have 2 times 6. So 2 times 6 is equal to, correct, it's 12. And of course, let's multiply the means. We have 3 and 4. So 3 times 4 is equal to 12. Since the product of the extreme and the means are the same, it means that the given proportions are equal or equivalent. So again, do not forget that the parts of proportions are the extreme and the means, not the antecedent or the consequent, because antecedent and consequence are the parts of a ratio. But in this case, the part of a proportions are the extremes and the means. Again, the extremes are the first and the last term of the proportion, and the means are the second and the third term of the given proportions. And again, for you to be able to identify if they are proportion, make sure that the product of the extreme and the means are equal. Question? Okay, so I think we can now proceed with our next presentation. Let's talk about the different kinds or types of proportion. So let's first talk about direct proportion. According to the definition given, direct proportion, when one quantity increases or decreases, the other quantity increases or decreases also. So let's have an example. In this example, both quantity increases. So mother uses 3 cans of milk to 4 glasses of water. How many cans of milk does she need if she has 8 glasses of water? If you're going to observe, on the first given ratio, we have 3 cans of milk to 4 glasses of water. While on the next given ratio, the number of glasses increase from 4 glasses, it now become 8 glasses. So since we are solving problems about direct proportion, remember that when one quantity increases, the other quantity will also increase. So we are expecting that the number of cans will also increase. From 3 cans, it will increase. So later on, we will find out what is the answer for this example. So again, remember that the direct proportion, when one quantity increases, the other quantity will increase. But when one quantity decreases, the other quantity will now decrease also. So let's check. For this problem, so we form a ratio 3 is to 4 is equal to n is to 8, wherein n represents our missing term or the number of cans of milk. So again, for us to be able to solve this, we have to follow to check the extreme and the means. So since that the parts of this proportion who has a complete value are the extremes. So we need to multiply first the extremes. And the extremes are the first and the last term. So in this case, we have 3 and 8. So 3 is the first term and 8 is the last term. So let's multiply 3 times 8 will give us 24. And now, to complete the process, let's now multiply our means. So we have 4 times n will give us 4n. And to get the missing term, we need to divide the product of the extreme to the product of our means. So let's divide 24 divided by 4. So 24 divided by 4, we will get the value of n, which is 6. So it means that we need 6 cans of milk to 8 glasses of water. So as you can see, the number of cans of milk also increases, as well as to the number of glasses of water. So that's the characteristic of direct proportion. Remember, when one quantity increases, the other quantity increases also. But when one quantity decreases, the other quantity will also decrease. So that is direct proportion. And now, let's have our next type of proportion, the inverse or the indirect proportion. So what is inverse or indirect proportion? So when we say inverse or indirect proportion, it means when one quantity increases or decreases, the other quantity will have an opposite change, just like a seesaw. So it means that if this quantity increase, the other quantity will decrease. If this quantity decreased, the other quantity will increase. So that's the characteristic of the inverse or the indirect proportion. Usually, we encounter problems with indirect or inverse proportion, usually in work problems, just like this. So let's have example number 1. So for example number 1, we have if 10 men can finish painting the building in 3 days, how many men are needed to finish the same work in 5 days? So if you're going to observe, there is an increase in the number of days. So since it is about indirect or inverse proportions, so we are expecting that the number of men who will work to that same work stated in this problem will decrease. So 10 men can finish painting the building in 3 days. How many men are needed to finish the same work in 5 days? So again, if one quantity increase, the other one will decrease. That's the characteristic of the inverse or indirect proportion. So let's solve. So with that problem, we notice that the two ratios that are formed are 10 is to 3 and n is to 5. So for you to be able to solve it quick or fast, so just identify which of the two ratios has a complete value, meaning there is no missing term. So obviously that is 10 is to 3. So what we are going to do is to multiply 10 and 3. So 10 times 3 will give us 30. Then now, after that, we are now going to multiply, of course, the other ratio. So that is n times 5 is equal to 5n. So the same thing, we have to divide the, the product of 10 times 3 and the product of n times 5 to get the value of n, or the number of men. So now, 30 divided by 5, the answer is n is equal to 6. Meaning to say that we have 10 men for 3 days. Now, we have 6 men for 5 days. So as you can see, on the first ratio, we have an increased number of um, men. On the other ratio, we only have 6. So again, that's the characteristic of indirect or inverse proportion. When one quantity increase, the other one will decrease. On the other hand, to the number of days, so 3 days is smaller than 5 days, so we have a decrease in number of days on the first given ratio. While on the other hand, we have 5 days. So there is a decrease on the first given days in our ratio. On the other ratio, we have an increase in the number of days. So again, that's the characteristic of inverse or indirect proportion. When one quantity decreases, the other one will increase. So that is about indirect or inverse proportion. Now, let's continue with partitive proportion. So what is partitive proportion? So this is the last type or kinds of proportion. So partitive proportion, a number is being divided or distributed into two or more unequal parts. So that is partitive proportion. A number is being divided or distributed into two or more unequal parts. So to form ratio in this case, so we can create, of course, we have the whole equal to a given ratio, or ratio is equal to the whole. The whole represents the number to be divided or distributed to unequal parts. So that's partitive proportion. Okay po? So let's have an example. So in this case, I have 30 marbles. I will give my marbles to Pedro and Juan in the ratio 2 is to 3. How many marbles will each of my friends get? So again, we have 30 marbles and the ratio is 2 is to 3. It will be given or distributed to Pedro and Juan. So to solve this, we need to identify the whole and the ratio given in this problem. So obviously, our whole part is the 30 marbles to be distributed or divided to the given ratio or unequal parts, and that is 2 is to 3. Then now, we can now create our proportion. So we have 2 is to 3 is equals to 30, or 2n is to 3n is equals to 30. Why I put n? Because remember, we are looking for the number of marbles that Pedro and Juan will receive based on the given ratio. So still, there is a missing term. So to solve this, we are going to add the given ratio. So we have 2n plus 3n will give us 5n. Then, after that, we can now divide the whole to the sum of our ratio. So our whole is 30 marbles and the sum of our given ratio is 5n. So 30 divided by 5 is equal to 6. So it means that the value of 6, the value of n is 6. So after that, after getting the value of n, we can now distribute it to our given ratio. The 2n is to 3n. So 2n is to 3n is equal to 30. Since the value of n is 6, so 2 times 6 is to 3 times 6 is equal to 30. So 2 times 6 will give us 12 and 3 times 6 will give us 18. So we can now have 12 is to 18 is equal to 30. To check if we got the right value of n, so simply add our ratio. So 12 plus 18 is equal to 30. So the answer is 30 is equal to 30. So it means that we got the right value for n, and that is 6. So it means that Pedro will receive 12 marbles while Juan will receive 18 marbles. So that is the partitive proportion. So we divide a whole or distributed the whole to unequal parts, to the given unequal parts. So again, don't forget that proportion is about two equivalent ratios, and the parts of our proportions are the extremes, or the first and the last term, and the means, which is the second and the third term. And to know if they are proportion, we have to multiply the extreme, the value of extremes, and the value of the means. If we got a same product on it, so it means that the given proportions are equal or equivalent. And the three kinds or types of proportions are, of course, we have the direct proportion, we have the inverse or indirect proportion, and last, we have the partitive or the partitive proportion. So that's it. So we have 12 is to 18. So 12 is the marbles for Pedro, and 18 is the number of marbles for Juan. And of course, in learning, you will teach. And in teaching, you will learn. Actually, this webinar is a two-way process. You may learn from me, and at the same time, I'm also going to learn from the viewers or the participants of this webinar. So it's a two-way process in learning and in teaching, most especially in mathematics. So according to Phil Collins. So again, Thank you, and I hope that somehow I shared to you a knowledge on how to teach and learn mathematics the easiest way. So again, thank you for listening, and I hope we'll see you again for more sessions about mathematics. Yes, sir.
Thank you so much, Sir Nico, for a very
Thank you, sir.
informative
Thank you, sir,
and a
Nestor.
very useful, interesting presentation and
Thank you, sir.
discussion. Hope our participants could be able to create or craft their own lesson or presentation using Zoom
Zoom application, sir.
and yes, sir, and able to upload it on YouTube, ready to use. Again, thank you, sir, and
Thank you, sir.
uh, to our participants, you can type your question in the comment box. They will answer your queries later. And claiming your certificate will be explained later. Thank you. Okay, now let's call our second speaker. He is also an educator, a master teacher, and presently teaching mathematics at Angeles City Science High School, Philippines. Sameo awardee and a regional outstanding public secondary school teacher and a gold service awardee of Boy Scout of the Philippines. He is a responsible, hardworking, goal-oriented, and dedicated, of course, God-fearing individual. Our next speaker will be sharing with us the K concept of proportional logic. Dr. Christian F. David. Welcome, sir. Sir, welcome. It's your
Hello.
turn now. Yes, sir.
Okay. He- Hello. Thank you very much, sir, for introducing me. With a well. Okay. So once again, good evening, or good morning in other places of the world, and good day to everyone, especially to our viewers who are now watching right now. And I would like to also take this opportunity to make shout outs or to shout outs my principal and my assistant principal back here at Angeles City Science High School, Ma'am Casarina David and Ma'am Garda De Jesus. Also my fellow educators. And shout out also to my students, to our students here, especially my advisory class, who are, I believe, are part of the 365 viewers right now. And to Mrs. Jennifer R. David. Okay, so once again, good evening, good day. My name is Dr. Christian F. David, and I am teaching mathematics for over 15 years now, and research for quite a while. And Today, I am privileged to share with you one of the topics in mathematics that is very important and interesting, especially in logic, the key concepts of proportional logic. So this is, you might treat this as like an introduction for the subject logic. Okay, so for today, uh, at the end of the sessions, the following are the objectives. First, we will going to illustrate a proposition. Second, we will distinguish between simple and compound propositions. And third, we will translate propositional logic into English statement and vice versa. Those are our objectives for today. Okay, so let us begin. Logic is the basis of all mathematical reasoning and of all the automated reasoning. The rules of logic specify the meaning of mathematical statements. The rules of logic gives or give precise meaning to mathematical statements. These rules are used to distinguish between valid and invalid mathematical arguments. Apart from its importance in understanding mathematical reasoning, logic has numerous applications in computer science, varying from design of digital circuits to the construction of computer programs and verification of correctness of programs, among others. Now, in order to understand logic, we need to understand the basic building block of logic, the proposition. What is a proposition? Well, it is a declarative sentence, and it is either true or false, but not both. So, as you can see by this definition, a proposition is a statement, or specifically, it is a declarative sentence that may be true or false in its truth value, but can never be both. That definition gives us two conditions for a given statement or given sentence or statement to be a proposition or not. That is, it should be a declarative sentence. That means to say it should not be an interrogative or a statement that is in question form or in asking information. Or it should not be imperative sentence also, like making commands or requests. And then also not to be an exclamatory sentence. That means to say like you are showing some emotions or emphasis. It should be declarative sentence. And this declarative sentence, as we've mentioned, it should be true or false. And the truth value of proposition is usually denoted by T, capital letter T, or 1 for numerical value if it is true. And F, capital letter F, or 0 in numerical form if it is false. And usually, propositions are denoted by small letters. Example given, um, P, Q, R, S, T. These are the common small letters being used to denote propositions. Let's have some examples for these propositions. Say proposition P represents the elephants are bigger than mice. The statement elephants are bigger than mice is a statement. It's a declarative sentence. So that's the one condition of proposition is met here. And number two, what is the truth value of this? Does it have a truth value? Yes. Elephants are bigger than mice. The truth value of it is true. So therefore, this proposition P, elephants are bigger than mice are or is a proposition. The next example, proposition Q. Today is April 5, 2020. Is it a declarative sentence? Yes, it is. What about the truth value of it? Is it true or false? It is false, but still, despite it is a false sentence, it is still a proposition because it is a declarative sentence and it has a truth value, but in this case, it is a false statement. So proposition can be false. No? It doesn't have to be true all the time. Another example here is proposition R. The function f of x equals x squared minus 3x plus 5 is a polynomial function. Obviously, the given statement is a declarative sentence, so the first condition is met, and the statement itself that the function f of x equals x squared minus 3x plus 5 is of course a polynomial function, so the truth value of it is true. So all of these given examples, the proposition P, Q, and R are all propositions. Now let's have this exercise for us to determine whether the given statement is a proposition or not. And if it is a proposition, then we will determine its true value. Okay. We can ask the viewers also to participate this one. They can chat their answer in the chat box and see if you're right or wrong. So I invite everybody. I invite the viewers if they can answer the given statement, if it is a proposition or not. And if it is a proposition, just give its true value. So let's start. Okay. The first statement is Luzon is the biggest island in the Philippines. Okay. Is it a proposition or not? I give you a few seconds to answer for this given statement. Okay. The answer is the given statement is a proposition and the truth value of it is true, of course. Luzon is the biggest island in the Philippines, followed by Mindanao. Okay. Let's move to the second example. 430 is less than 50. Is the given statement a proposition or not? The answer is it is a proposition. And but this time, the truth value of it is false, of course. 430 is not less than 50, so but still a proposition. Let's move to the third statement. 6 plus negative 3 equals 3. Is it a proposition or not? And the answer is it is a proposition. And the truth value of it is, of course, it is true. Or we can write that as just use the capital letter T. Moving on to the fourth example or fourth statement, is this a proposition or not? What is the domain of the function? Again, I invite the viewers to participate. You can share your answer to my questions if you think the given statement is a proposition or not by just um, writing your answer in the chat box. So what is the domain of the function? That's the given statement. Is it a proposition? The answer, it is not a proposition. Why is that so? Because the given statement is not a declarative sentence. Remember, there are two conditions for it to be a proposition. The first one, it should be first a declarative sentence. Since the given statement, what is the domain of the function, is an interrogative or a question form statement, so that makes it a not proposition. Okay, so I hope you are following the idea and you are getting the idea of it. Okay, let's have more. What about this? Y equals 2x. Is that a proposition or not? Okay, the answer is not a proposition. Okay, the explanation for this one is that though the first condition of it is met, that is, it is a declarative statement, it is a declarative sentence, y equals 2x, it's declarative, yes, but the second condition, that it should have a truth value, either true or false, but not both. Y equals 2x, since it contains variables x and y, that means to say we do not know the certainty of its truth value. We do not know if it's true or not unless we know the value of x and y. So at this point, y equals 2x is undetermined for its true value, so it is not a proposition. Okay, let's move to the next one. Welcome to the Philippines. The given statement, is it a proposition or not? If you think this is a not a preposition, then you're right, because the given statement, it's not a declarative. So the first condition is not met. So the statement "Welcome to the Philippines," it's not a preposition. So meaning to say, if you get the idea, if it's not a declarative sentence, whether it is an interrogative, imperative, or exclamatory sentence, then that makes it not a proposition. So if it is already not a declarative, then you don't have to move to the second condition to whether it is true or not, because in the first place, it's not a proposition. Okay, let's have the third or the final example for this one. My seatmate will get a perfect score in the logic exam. Is it a proposition or not? Come on, guys, you can write your answers in the chat box and try to like check or at least guess the answer for this one. My seatmate will get a perfect score in the logic exam. Is this a proposition? If you think it is a proposition, then you're right. It is a proposition. First condition, it is a declarative sentence. Check. So it is met. The given statement, my seatmate will get a perfect score in the logic exam, is really a declarative sentence. Now, what about the second condition? Is true value. Is it true or false? It is true or false. It depends. No, although the statement is written in the future tense, no, but one thing for sure, the seatmate, either he will get a or she will get a perfect score or not. So, but there's one thing for sure to happen, either a perfect score or not. So it can be true statement or false. That is certainty to happen. So it's still the second condition is met at this point. So the last example for that is given, my seatmate will get a perfect score in the logic exam, is a proposition. And the truth value is still undetermined, true or false. Okay? So I hope you get the idea of the proposition. Let us repeat that a proposition is a declarative sentence that is either true or false, but not both. No? Given that definition, it should be the given statement for it to be a proposition must meet the two conditions. It should be a declarative sentence, and number two, it should be true or false. So meaning to say it has a true value. Let's move to the next one, logical connectors. Now, just like in English, there is what we call compound sentence, which is this is a kind of sentence that join two or more sentences or independent clauses with that have related ideas of equal importance, joined by coordinating conjunction. So similarly, in logic, we have also compound propositions. What are these propositions? These are propositions that are combined to form a single one, no? And using what we call logical connectors. Okay, but do note that a proposition is said to be simple if it cannot be broken down further into other component propositions. Okay, so we call that simple proposition, or in other articles or other books, we call the atomic proposition, meaning to say we really cannot have it or it down further into other component propositions. Okay, let's have an example here. Proposition P, say today is Saturday, and proposition Q, math is blue. By the way, the given proposition doesn't have to be like it has to be like making sense all the time. We after here is that we are trying to analyze if they are following the and meeting the criteria for propositions, and we can get the truth value of it later on. Okay, so it doesn't have to be or to make sense all the time. So the given propositions are today is Saturday and math is blue. And if you notice, the proposition P, today is Saturday, is a simple one. Okay, it's a simple propositions, the two of them, because you cannot break the given statement further. Okay, so it's already a simple one. But these two propositions can be combined using a connector, logical connector N. So we can say that if you would like to combine them to form a single proposition, call it compound proposition, we can use the connector N to make it today Saturday and math is blue. Okay, so the given now it becomes a compound proposition. So in this example, I hope you can see the difference between simple and compound. So simple propositions cannot be broken. They are like already um, cannot be have another proposition out of it. So it cannot be broken down. And then compound proposition can have two or more proposition that is combined by logical connectors. And the given compound proposition today Saturday and math is blue in symbols can be written as P and Q. If today's Saturday is represented by the proposition P and math is blue is represented by Q, then we can write down in symbols as P and Q using this symbol conjunction N. Or this is kind of the similar to hat. No? P and Q. This is read as P and Q. So more about the logical connectors in the next slide. Okay. So we've mentioned the logical connectors are used to form compound propositions. We may use them to form compound proposition. And some of the logical connectors that we are using in basic logic are the following. We have the not P, the not, the word not, the word N, the word that we used a while ago, the word or, and the if then form, and also the if and only if. The not word is called the negation. No? The name of it is negation. That means to say you take the opposite of it, the truth value of it. So you put the not. So you call it negation. And the symbol of it is this one. This is the negation symbol. For the N connector is we call that conjunction. And we use this symbol, conjunction symbol for or to denote conjunction. So that is read as P N Q. Okay. The word or is called disjunction, and it's represented by these symbols like V. No? So if we have two propositions to form a compound proposition using a disjunction, then we can have a symbol like this. And it's read as P or Q. The if then form is called implication or sometimes called conditional. Okay. And it is represented by the symbol arrow, this arrow right here. So if we have P and a proposition Q, and then we have statement like this, written like this is read as if P, then Q. If P, then Q. That is what we call implication or conditional. The last one we have the if and only if. If you notice, we are now using a double-headed arrow here. This is called the biconditional or material equivalence. No, so if we have biconditional or material equivalence, it is written in symbols as this, and is read as P if and only if Q. Okay, that is read as like that. Okay. So let's have this another exercise 2, for us to use the concepts. Okay, first we will translate the following into propositional logic. Given the following propositions, say proposition P is given as you can drive. Proposition Q is you have a driver's license. Proposition R2 is an even number. And proposition S is math is interesting. Okay, so we will be having these examples 1 to 5, and then we will translate them into propositional logic, meaning to say in symbols. No? Given those P, Q, R, S as our symbols for these given propositions in the box. Okay, let's try the first one. 2 is an even number and math is interesting. Okay, so okay. So if you notice, the given statement is a compound proposition. We have the first one, 2 is an even number right here. And the other one is math is interesting. So as you can see, the 2 is an even number is represented by the proposition R. Okay. And math is interesting is represented by the proposition S. Okay. And if you remember, the logical connector N is denoted by the symbol like inverted V. This one is represented by that symbol. And so to write this into a propositional logic, we can write that as R N S. Okay. That is the given, or that is the answer for that one. So 2 is an even number and math is interesting. If we will translate that into propositional logic, that is written as R and S. Okay. So I hope you got that one. Let us try to answer the second example. Okay. This one is either math is interesting or you can drive. Okay. So here the word either or is used. No? Either and or. Okay. But let us focus our attention first to the given or to the proposition involved in the second example. Again, math is interesting here, right here. The math is interesting is represented by S. And then you can drive is represented by P. Again, the compounds proposition need not to be or to have sense, no, at all. Uh, our task is to translate this to propositional logic. So either math is interesting or you can drive. So this can be written as, okay, okay. By the way, the connector is either or simply or, okay, okay. That or, sorry, okay. That or is of course represented by this symbol. Okay, it's like V. Okay, it's like V. So therefore, if we have that one, then we can write our propositional logic as this. Okay. So therefore, we can write that as S or P. Okay. This is our propositional logic for the given or second statement. Either math is interesting or you can drive. Okay. So I hope you are getting the idea of it. Let's move to the third example. Okay. If 2 is not an even number and math is not interesting, then you can drive. Now, this given statements is obviously contains three propositions. Okay, so let us analyze it. Let us break it down the proposition so we can write the propositional logic. Okay, the first one is obviously we can see that here's the first two is an even number which is represented by r. Okay, and the other one is um, math is not interesting. Okay, and then you see there's a word here not, no? So the word math is interesting is represented by s, but you have not, the word, the connector not. So instead of writing s and it used the word not, you need to negate it, no? So you need to negate s because the given has the word not. So math is not interesting, so you can be written as negation of s. Okay. Then the third proposition here is, okay, you can drive. So you can drive. Okay, you can drive is represented by p. Now, if you will going to analyze it, then we can see that there is a word if and then there's a word then there. Okay. So, meaning to say that all of this is part of the if, all of this is part of the if, and that one is part of the then. Okay. So, we can write that as this one, but we almost forget that this word and. Uh, okay. The connector and is, of course, represented by this symbol hat. Okay. For you not to be confused, whether you going to use this one or the V or the disjunction, there's kind of a clue here. No, there's kind of a hint. The word N, okay, A. This symbol right here, the inverted B, resembles the letter A. So yeah, get the idea is similar to A, so N. No, otherwise you have to use the V or the disjunction or. Okay. So finally, we can write it down as, okay. So okay, we can write it down as R and not S, but we need to group this using a parenthesis. This is part of the if. No, this is the part of the if. Okay, then, okay, then you can drive. That is P. Okay, so now this would be our propositional logic. So we have an answer R and not S, then P. Okay. So that will be our propositional logic. So we are translating the given statement, an English statement, into a mathematical or propositional logic, which in turn, after this lesson, ideally will be followed by the truth value of these propositions. We will analyze the truth value of given propositions. Okay, so this is the answer for it. I hope you are getting the idea. Moving on to the fourth example, you can drive if and only if you have a driver's license. Okay, so you can drive if and only if you have a driver's license. So in this example, we have two propositions involved. The first one is you can drive, and the other one is you have a driver's license. And of course, the first proposition is denoted by P, and you have a driver's license is denoted by Q. And the connector if and only if you remember, this is a biconditional material equivalence, and we use the double-headed arrow here. Okay, so there you go. Okay, we have translated the following statements and the connectors into symbols. So all we need to do is to write it now. So the propositional logic would be P if and only if Q. Okay, that is our propositional logic. Meaning to say in English, that is you can drive if and only if you have a driver's license. Okay, that is the given statement, and this is the required propositional logic. Okay, moving on to the fifth and our last example for this exercise. No? The fifth statement says, if you have a driver's license and math is interesting, then 2 is an even number and you can drive. Okay, so in this example, all of the propositions are used. And then, but you have to examine the connectors. Okay, so we have a connector here and, okay, we have also a connector here and, but they are connected by this if and then. Okay, so you have to take note of that in order for us to write the propositional logic. Okay, so obviously the this one is you have a driver's license, that is Q, and math is interesting is S. The other one is, okay, let's change the color. 2 is an even number. Okay, which is represented by R, and you can drive is represented by P. So okay, so we can now write our propositional logic. So the first one is you have a driver's license and math is interesting. We can write that as, okay, as Q and S. But we need to group this because this is part of the hypothesis or the if statement. Then moving on to the next one. Remember the if then is represented by this conditional symbol arrow. 2 is an even number. So we have 2 is an even number, is denoted by R and P. And then we need to group that, no? In order to emphasize that this is one group and part of the then statement. 2 is an even number and you can drive. So that is represented by R and P. So our final answer would be, okay, Q and S if, or if Q and S, then R and P. That is our answer. Okay? If you're getting it, the idea. Now let's have the other way around. Let's have the other way around. So let's have this exercise number 3. Now, we'll be having these symbols, the propositional logics. Then we will be translating them into English statements. So this is like the reverse process of what we had a while back. Okay. So this time the given propositions P, Q, R, S are different. Proposition P is square root of 2 is an irrational number. Proposition Q is logic is fun. R is you study hard. And S is you get good grades. Okay. So we will be translating these three into English statements. Okay. So let's start. So the first one is we have P and Q. So this is read as okay. This is read as P and Q. Okay. So P is denoted by square root of 2 is an rational number. Rational number. Okay. That is P. And then we need to write the word N as the logical connector and write the Q then. Proposition Q. Logic is fun. Okay. So this is the given one, and this is the answer. This is the equivalent in English statement. So square root of 2 is an irrational number and logic is fun. Okay. Quite easy, no? Quite easy. All you have to do is to, of course, get to know the logical connectors. Then after getting the logical connectors, you just kind of analyze it, especially if you have more propositions involved in a given propositional logic. And then just substitute the statements for the proposition, say P or Q. Okay, let's have the other one. Okay, so square root. Oh no. The given is P or R, or if P or R, then Q and S. Okay, so as you can see, all the prepositions are used here. So P or R, then Q and S. So let's start. So we start first with the this one. Okay, this one. So remember the whole statement here is been uh, is understood to be an if then format. That means to say this underline P or R that is part of the hypothesis or the if, and the Q and S that is the part of the consequence. Okay. So let's try to have this first. So P or R that is P if, okay, that is part of the if. If square root of 2 is an irrational number, irrational number, okay, or, okay, or that is this one, or you study hard, you study hard, okay. So we just have accomplished and written the first part of the if then format, if then compound statement. If square root of 2 is an irrational number or you study hard. Let's move now to the second part of it. Then. So if then format. So then Q and S. Q is denoted by L. Logic is fun, and N, conjunction N, and then S. You get good grades. Okay. So that's the second part. Then logic is fun and you get good grades. Okay. So that doesn't really make sense, but this is the equivalent of the this one into English statement. So if square root of 2 is an irrational number or you study hard, then logic is fun and you get good grades. That's the equivalent English statement of this symbol. Okay? I hope you are following. And if you do have any questions, just write it down in our chat box. Okay, so moving on to the third example. I hope you got this one. Okay. Okay, so how do we read the third example? We are using this one. This is the biconditional or the material equivalence. So we have also a compound statement in the first part and also a compound in the second half. So this is R, R and not Q if and only if P and S. Okay, so I repeat, this is R and not Q if and only if P and S. So how do we write that in the English statement? So first, let us have the first part. No? Okay, so the first part is this one. Okay, this is the first part. So R is you study hard, so we'll write that as you. Okay, you study hard. You study hard, and then this symbol is conjunction, meaning to say we will be using the word and. Okay, you study hard and Q. We'll use the Q, but we will negate it because of the presence of the negation symbol. So and logic is not fun. Okay, so when you negate a proposition, usually you use the word not. Okay, or you may use also it's it's not the case. Okay, it's not the case. You may also use that. It's not the case that logic is fun. It's not the case that logic is fun. Okay, that can also be written, no? Or simply you can just write logic is not fun. Okay, but most of the time this is the way we write it, but not all the time. That when we negate, we put not. There would be other examples that we don't usually use the word not. Uh, Example, um, if 2 is even, okay, so we can write that as negation of it is 2 is not even. Okay, that's fine. But if we write that as 2 is not even, we can also write it as 2 is odd, which is quite simpler than the first one. No? So not all the time that we will be using not. So sometimes we can use the other name of it, but in most of cases we use the word not. Okay, so let's go back to the given problem. Let's erase that one. Okay, so that's the first one. R and not Q is you study hard and logic is not fun. Okay, and then comes this biconditional. If and only if and only if, yeah, that is the connector. Then we move to the second part, P and S. P, what is P? Square root of 2 is an irrational number, rational number, okay? And then N, okay, that's the logical connector, and S, you get good grades, okay? So that's the second part. So square root of 2 is an irrational number and you get good grades. So therefore, our answer for this given logical propositional logic is in English statement is written as you study hard and logic is not fun if and only if square root of 2 is an irrational number and you get good grades. Okay? So all of the connectors are written, all the propositions are written correctly and properly. So therefore, this is the needed English statement. Okay? So I hope you get that one. That is our third example and our answer for this given propositional logic. Okay? So in summary, propositions are declarative sentences that are either true or false, but not both. Okay, so the definition itself gives us two conditions for a given statement to be a proposition. The first one should be a declarative sentence, and the second one is it should contain a truth value, either a true or a false, but not both. Okay. And then we also discussed in our presentation that a simple propositions are propositions that cannot be broken down further into other component propositions. So they are also called atomic because they are already a simplified version of a statement. So we call them simple propositions. But if we have one and another propositions or even more propositions, we combine them using a logical connectors, then the given the uh, outcome or the resulting proposition is what we call compound proposition. So you have the idea now that compound propositions contains two or even more propositions, simple propositions that are connected using logical connectors. And what are the some of the logical operators we use in logic? Usually, we have the not. Okay, we have this one, the not. This is called the negation, and the symbol is this one. Okay, and then we have the conjunction and. Okay, this is the conjunction. Okay, sooner or later you will be familiarizing this as we are discussing this one, or if maybe in time you are studying logic, you'll be familiarizing with the words. The n is a conjunction, and we are the symbol that we are using is this one. It's like the hat, no? So again, for you not to be confused with the word or the disjunction on the other hand is using the symbol like v, no? So for the conjunction, it resembles a, no? For the word n. So that's why you should remember that the symbol is an inverted v. Otherwise, the word or is a disjunction and use the word or the symbol v. The if then is a what we call the conditional, conditional, and we use the symbol like this. And the if and only if, this is what we call the biconditional. Okay? And we use the double-headed arrow for its symbol. Okay? So these are the five common logical operators that we use in logic. Okay? So I hope you get all the concepts presented here for the key concepts of propositional logic. This is like the introduction for this. And as I uttered a while back, this leads us to the next lesson, which is the truth value, getting the truth value of this compound proposition. But then again, let us test ourselves. Let me invite everyone in our viewers, the 390 plus viewers, to play. If you have the gadget with you, can you open another tab and you please proceed to go to kahoot.it. Okay, so let's play Kahoot here. And then the pin number is to be used is 1342670. 1342670. Okay, so let's play a game in using the application Kahoot. Okay, or Kahoot. Okay, let's wait for others to join our game. Okay, let me share another screen showing the Kahoot or the Kahoot. So we have about 20 players already in the Kahoot. So I invite still the others to join us in this game. And let us check our knowledge. If we got the concepts presented a while back. Players already in the Kahoot. So I invite still the others to join us in this game. And let us check our knowledge. If we got the concepts presented a while back. Okay, so we are now 53 in the Kahoot. So let's wait for more few more minutes. Maybe after 1 minute, then we can start. So for those who are still not in the Kahoot, please go in the kahoot.it and then use the game pin 1342670 to join in our game. Okay, so I guess in 10 seconds we shall start. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. For those who cannot play with us and fail to join with us, sorry, because we have a limited time only, so we need to start. Okay, so my apology if I will start it now. Okay, thank you. So let's start now. Okay, first quiz. Okay, proposition or not. This test is not or is easy. This test is easy. That is the given statement. Is it a proposition or not proposition? The answer is it is a proposition. So 13 got it correctly. So come on, guys, can still have the other questions. Okay, let's move. Okay, let's move. Proposition or not? Mabuhay. This is a common expression in the Philippines, especially if you are welcoming or like trying to cheers other persons. You may call, you can say mabuhay or long live in English. Is it a proposition or not? Okay, time is up. 34 got it correctly. That is not proposition because this is not a declarative sentence. Remember, it should be a declarative sentence. Okay, so that's okay for those. Try again for our next question. Okay, so let us see who is leading. And so far is Nick Z or Nick Z is leading the group, followed by Bacalso and then ABN. Third question out of 10, proposition or not? Smile at the camera. Is that given statement proposition or not proposition? Okay, so smile at the camera is of course not a proposition. Why is that so? Because this is a like imperative. Now you are trying to request no, someone. It should be a declarative, not interrogative, not imperative, not even interrogative statement. Okay, scoreboard. We have Burned this time to be the leading scorer. Then ABM is now the second placer, followed by Miss Beauty. Fourth question, again, proposition or not. If an integer is even, then its square is also even. Okay, so let me help you. Is it first a declarative sentence? If so, does it have a truth value? Okay, so by that, you can see, I can decide if it is a proposition or not. Okay, time's up. The given is a proposition because it is a declarative and it has a truth value. Okay, the truth value is, of course, true. So the square of an even is, of course, an even. So 45 got correctly. And this time, the leading is Jasa. So we have um, changing turns of leader in our scoreboard. Okay. So the big question here is that we will finish first after the 10th question. Okay, fifth question for the final question similar to this one, proposition or not. The Philippines is a Southeast Asian country. Is the proposition or not proposition? Okay, so ask yourself, is it a declarative sentence or not? Okay, this time, the given one is a proposition, no? Because the Philippines is a Southeast Asian country, is a declarative sentence, and it is a true statement. So 50 got it correctly. Congratulations. Now this time Jasa still leads the team or the group, and then followed by Bacalso and then Beauty. Sixth question. Okay. Okay. I hope you can see it clearly. The given proposition. Basketball is a nice sport and logic is fun. How do you write that in a propositional logic or in symbols? Is this one or is this one? The pink or the blue? Okay, so the connectors end, so we need to use this symbol. So the pink or the red is the correct answer. Okay, so let's see who's now the leading one. Is Bakal, so this time leading the pack. The seventh question, either 4 plus 1 equals 5 or penguins are birds. Again, please use the given um, propositions in the box. Familiarization of the symbols for the connectors is also very important here, no? So half no, half 34 got it correctly. Okay, this time the leading still Bacalso. Congratulations. Okay, keep it up. I hope you can get all the answers correctly. Remaining questions. If basketball is a nice sport and penguins are birds, then 4 plus 1 equals 5. Okay, how do you translate that into propositional logic? Is this the red one here or the blue right here? What do you think is the correct answer? Okay, time is up. The correct answer is the red one. Right? So we have P and Q, then S. Right? So who's the leading scorer this time? Oh, Jasa this time is the leading and Bacalso drops to second place. Moving on to the ninth question, second to the last. Okay. Okay, now this time is we do the reverse one. Given this one, what would be the equivalent in English statement using the propositions in the box? Okay, so this one is this one. So either basketball is a nice sport and penguins are birds, or 4 plus 1 equals 5. So I hope you get the idea there. There is a kind of a grouping symbol here. So using the parentheses. And the leading scoring this time is still Jassa. Okay, congratulations. And then followed by Bacalso, then Randolph Virai. Okay, final question for this game. We have that symbol, propositional logic. What is the English statement equivalent to this symbol? Is the red one or the blue one? Okay, time is up. The answer is the blue one. So basketball is a nice sport, and either penguins are birds or logic is not fun. Okay. So now finally revealing the podium. The third placer got 6,539 is Expert Lemmings. Very good. Congratulations. Then Randolph Fry. Congratulations. And finally, Jessa. Congratulations. We have
Hello,
runner
sir.
up.
Hello, sir. Can you hear me?
Yes, sir. Yes, sir.
Sorry to stop here. Uh, sir. Again back to Kahoot. Again back to Kahoot. Still available? That is.
Sir.
Kahoot is still available. Hello.
Yes, sir. Yes, sir. I can hear you, sir.
Yeah, I just want to know that Kahoot is your result, first, second, and third. Its result is still available to see what the first and second and third.
Yes, Jessa is the first placer.
Can you show them in screen?
Uh, okay. But unfortunately, sir, it already kind of
Okay.
erased the result.
Do you have any record of top three? I mean, their email ID or something.
I remember Jess is the first one, but
Yeah.
was I I failed to remember the second, third. We can
Mhm.
ask the viewers who is the second and the third placers.
Okay. It's a request that those who are top three, first, second, and third. It's a simple request. Please contact with us in our Facebook page inbox. We have a small special gift for you. That is, we will going to recognize you with the quiz competition certificate as the top merit, first, second, third. So it's a
Wow! Congratulations,
yeah.
sir. I have a screenshot here. The winners. The first placer is Jasa. The
Yeah.
second one is Randolph Vry, and the third is Lemming 36 per T Lemming 36.
Oh no, no.
Uh,
Okay. So I think you have also their email in Kahoot.
I'll check, sir. In the Kahoot game, sir, they can use a pseudonym. Um, so otherwise, they need
Oh, no
to
problem, no
reveal
problem.
themselves
Our
who is.
participants are always legal way, so no issue about that. And I think they will contact in our Facebook page inbox for their special recognized certificate for quiz competition merit list first, second, third. So
Yeah.
it's my honor to serve the certificates with them and by the support of you, sir. Sir, you may continue.
Okay. Thank you, sir. So there you go. Congratulations once again. You will be receiving like a special citation for joining our game, a quiz, a simple quiz show for our this particular topic in the key concepts of propositional logic. So once again, um, the following persons are the winners. The first place is Jasa. Second is Randolph Dry, and third is Per Lemmings 36. May I request you to please type in your name, your identity, so that in the certificates your names will be appeared. Okay. All right. Thank you and congratulations once again. So let me share the another presentation of mine. So I'm now about to end. But before that, of course, I would like to thank all the viewers for joining the this webinar, and hope so you learn from the first speaker up to this uh, time to this talk of mine. I hope you learned a lot, and thank you for your time and your patience for attending the webinar. Thank you also for your attention. And likewise, I would like to take this opportunity to acknowledge the Institute of Global Professionals, or the IGP, for the opportunity and the experience. It's been really a very good experience that I share with you some of the knowledge in part of the logic to everyone, especially to the viewers. Also, special thanks to Dr. Nestor Nuesca and Ma'am Esperanza Malang, our supervisor in the region and division respectively, for the invitation. With that, I would like to say thank you very much once again, and take care and stay safe. Thank you.
Thank you so much, Sir Christian. This is a slightly difficult topic, sir, but you did it very easily and clearly for our participants to understand. I recalled when I was taking up my advanced electronic subject in my computer tech, where logic gates and logic circuits were taught. The words not gate, and gate, and or gate, SOR gate, and XNOR gate were used also, with a given symbol and truth table, where 0 and 1 were used as part of Boolean expression. Your topic, sir, I think is likely related to digital logic gate of integrated circuits. Perhaps this is one application of your topic proposition. Again, thank you, Sir Christian. Hope the IGP can invite you again next time. Good luck.
Thank you also, sir.
Thank you so much. Thank you so much, sir, for your time and presentation and total approach. And I also saw that in the comment section, it's most engaging with your topics. That's why I put a note in screen IGP teaching mathematics. Because previously teaching mathematics, we already conducted another topics by the help of Dr. Nestor, teaching mathematics also. Also saw that in mathematics, I'm not too much interested in mathematics because I'm weak in math, but our participants is too much interested in mathematics. That's the point, and we'll get more encouraging and more support from you. Definitely we'll do lots of webinars like mathematics. And one more thing is that in this running month we have more 4 webinar related with mathematics. So it's total by the support of Dr. Nestor, and also you guys also support me. That's the reason. And so thank you so much again. Thank you so much, sir, for your time and for your valuable presentation.
Thank you. Pleasure is mine, sir.
Thank you, sir.
Yeah. Okay, dear participants, you know that better from me. What about the certification procedure? Today we are not going for a Q&A because it's already 4 minutes late. So today no more Q&A, and already you enjoyed from the both speakers by Kahoot and by slide presentations. So now it's time for certification procedure. This is the process for all the system are same. You have to log in our website www.eduigp.com, and you have to if you are new, then you have to create a account. I mean, sign in or sign up. Then select your topics, and you can see the button enroll now in upper of the description. So click on enroll now, and if you already enrolled, then click on the at the same button, get your certificate. So you can achieve your certificate at a time, and you can verify your certificate from anytime, anywhere. Our next webinar will be held on 7th April by the topics of improving self-belief and accomplishing your goals. And it will start 7 p.m. BST plus UGC plus 6. So see you again in the next session. And I already maybe sorry, I'm not sharing the link in comment section. Give me a moment. Give me a moment. Okay, I just shared the link in the comment section, so you can check and you can find the link in comment section, and I will put into in the I will yeah. Just give me a moment. Yeah, I just pinned the comment. I just pinned the link in comment section, so you can also click here. And also I shared the link in comment section, so you can also click the link from comment section also. Or if you are not from directly in our Facebook page, so you can log in www.eduigp.com, then you can find the course at the top of the website. So thank you so much, and thank you so much. See you again in another session, next session. If you oh, sorry, one more thing is that um, Ghansham Dashrak and those three who are winner of the Kahoot quiz, please contact with us with your full name, because your full name is so much important to appear in the certificate. So contact us in our Facebook page inbox. And thank you so much. See you again.